Hello and welcome to this short lesson on the Sage CRM REST API. Sage CRM exists in an ecosystem of different systems, and out of the box it integrates with a host of different Sage accounting solutions across the world. Sage CRM is part of a family of products that make up the Sage Business Cloud and provide the sales, marketing and service features for products such as Sage 300 Cloud or Sage 200 Cloud. We believe the addition of the REST API changes the game for developers and anyone working to integrate Sage CRM with other web-based systems. The REST API enables communication between desktop server, web and cloud applications and a broad common interface for all Sage products, as well as allowing data and business logic to be shared with web and mobile clients. The full API covers basic reading, writing, updating and deleting of data between different aspects of the system, as well as more complex functions such as control of security and access, the discovery of metadata, error handling and options for increased performance. From when Sage CRM was first developed, the product has always been open to integration and extension. There's a range of integration API options that can be used to address customer-specific integration requirements, and options allow for the extension of the interface and integration with third-party systems. The Sage CRM API is open, and there's also an open SOAP web services interface. So both SOAP and REST web services provide a powerful basis for integration with third-party systems, and this is especially true when we need to exchange data between systems scattered throughout the web, as both these APIs allow for remote system interactions and authentication to perform CRUD, create, read, update and delete actions within Sage CRM. And the presence of two web services interface in Sage CRM is a product of its design and the fact that Sage CRM is a system in transition from one architecture to another. You can read more about the REST API at help.sagecrm.com, and it's within the Help Center that you can find details of the REST API reference, and within the REST API reference, that's where Sage is going to be focusing much of its efforts in improving the capabilities of the management of data insert, update, and delete for use in integrations. The documentation contains examples of how to carry out actions on all of the supported entities. We think that REST clients are essential when developing RESTful web services, and you can use any web browser really to test GETs, but REST clients also provide formatted views of the XML and JSON payloads, which is very helpful when you are developing more sophisticated behavior. And with a REST client, it's very easy to perform all of the HTTP verb and actions to hit the RESTful web services post, put, and delete endpoints. And we think that there are two very helpful REST clients, the Advanced REST Client and Postman. During this training session, I'm going to be illustrating the techniques using both of the REST clients to perform GETs and GET on different endpoints within Sage CRM. The use of the endpoints makes it very easy to be able to copy and paste the different payloads that might be returned from, a GET, to be able to change it slightly in order to learn how to construct the payload necessary to be able to carry out a post back into CRM in order to create a new resource or change an existing resource. Now, this lesson is very much an introduction, but I'm going to consider the following points within this lesson. I want to be able to think about what is REST itself, how we handle application security, how we work with the data, how we understand the data that's available, and looking at some examples of create, read, update, and delete using the API, explore what limitations there might be with the REST API, and think about how we can perform it to change its performance tuning in order to get the best out of the API. So let's start with the first question: what is REST? Well, let's have a look at this screen. This is a screen grab from the Postman REST client, and you can see that it's made a request to fetch data from Sage CRM. And so Postman is an example of an especially useful REST client. As part of the documentation for the REST API, we've actually made available a Postman collection, a set of examples that can be used to demonstrate create, read, update, and delete actions on the notes table. But this is the general structure that we would expect to be able to retrieve data from the company entity. And you can see that we've got the form of, there's the server, that we're referencing S data in the path, then install name with this install name J, and then Sage CRM 2, and then going on into where it references the entity and then a specifier as well. Now, this is a request in to retrieve information. We can see that it's using the HTTP method get. That's the HTTP verb. And it's important to note that access to data via the REST-based interface is controlled by security. So this request is also authenticated. And you can see that the REST includes within the HTTP header the base64 encoded user credentials. Here, I issued a get. Now that was an HTTP verb, and there are actually other verbs like patch and options, but I'm going to concentrate just on 4 verbs to make my point. These are get, post, put, and delete. The Sage CRM REST API follows the architectural principles inherent within representational state transfer. That's what REST stands for, representational state transfer. So REST uses stateless interactions. The Sage CRM REST service doesn't use login sessions or store any other state information on the server. And instead, it's the job of the client to maintain the information about each resource. And it communicates over HTTP, HTTPS, and you can see that the importance of using HTTPS in a little bit. But the REST service uses common HTTP methods following the RESTful principle. So get is all about reading data, and it doesn't imply any change in the application state. Post creates resources and queries for data using conditions. Put updates resources, and delete removes resources from the database. Now you can see here that the use of the HTTP verb lends itself to making any actions within the database easily understood. So get reads the data and doesn't change the application state. Well, that corresponds to the SQL action select. Post creates a resource and queries the data using conditions. That's very much a select, that's very much an SQL action for the insert. Put updates resources, so you can think of that as an action update, and delete removes resources from the database, so that's the SQL action delete. That's the way in which we can map the HTTP verb with the SQL behavior. And a RESTful URL can be broken into a number of sections. So here, if we look on the screen, it's saying that we've got the idea of the host and port, first of all. That's my server. Then the my application, which is the context path. Then there might be a widget, which is the type of resource. And then you've got a specifier within that. So working with the Sage CRM REST API, it's the widget part of the URI that will chiefly determine the data that's to be returned. And if we look at a more realistic representation of what's going on, we can see that this is the general structure to retrieve data from an individual company record. So we can see that it's got in here, so my server, sdata2, install name, Sage CRM, then into entity. So and company is the type of the resource that we're going to, and we can think of that as a type of noun, and then 28 is the specifier indicating which individual company that we want to get. So we know that we're finding the data because the HTTP verb is a get. Now, by their very nature, RESTful APIs are designed to take advantage of existing protocols. So theoretically, the concept of representational state transfer, or REST, can be used over nearly any protocol. Within the context of Sage CRM, our API is taking place over HTTP and HTTPS. And we expect developers and integrators are going to want to access the API from a wide variety of locations, both inside and outside of the corporate network, and that means that they'll be accessing it from a range of different devices. So it means for us that when planning a development, some thought will need to go into the questions of who can access the system, where can they access the system, and where or what can they see and what can they do inside the system. So we do need to consider the authentication of any interaction, the application security applied, the network security, and the database security. Here in this slide, we can see that we can pass credentials in a request issued by a program written in C#. So this is the type of thing that we start to assemble the headers in order to make a web request. Now you can see that the web requests includes within the HTTP header the base64 encoded user credentials, but please be aware that I'm going to say that base64 encoding is nothing to do with security. So it is actually vital that interactions are carried out over HTTPS, not plain HTTP. The idea of base64 encoding allows us to represent binary data using only a limited common subset of the available characters, and security is not the intent of base64 encoding. Rather, encoding turns non-HTTP compatible characters that may be in a username or a password into those that are HTTP compatible. So if we consider the idea of authentication over HTTPS a little bit more, let's have a look at this. You see, REST authentication mechanism requires us to transmit the username and password in each transaction. Now, please note that the Sage CRM server itself doesn't know the password. It only stores the hash of the password and username, and that uses and it actually uses a bcrypt. So the hash strength is adaptive and it's assaulted. This means that we are going to have to pass the credentials on each request. So the transfer of the user credentials in each transaction means that we have to rely on HTTPS to protect this password in flight. So HTTPS is kept secret by encrypting it. HTTP keeps the data secret by encrypting it as it moves between the client and the Sage CRM server. And so that means, what HTTPS means is ensuring that anyone listening in on the conversation can't read anything about the data in transit. And that includes your ISP, a hacker, anybody else who manages to position themselves between you and the web server. And so that means that we only recommend that you access Sage CRM on public-facing servers over HTTPS. So you need to ensure that customers have installed their Windows updates on their Sage CRM servers and have updated their client browsers as well to the latest versions. Make sure you keep up to date because of security issues. Now, users in Sage CRM can be set up so they experience Sage CRM in very different ways. So individual users will authenticate in the main interface using their username and passwords, but because they belong to different teams or they are assigned different security profiles, they will find that they have different rights. And so if we consider just pulling back a list of companies here, we could make a request and have it come back. And in this case, we can see that the user credentials have seen a company has been returned, and any valid user credentials in Sage CRM can be used to log on to the main interface. So any that can be used to log on into the main interface can also be used to carry out transactions using the REST API. But what the user can see or do is subject to the rights defined by the security profile and the field level security. If in the main interface these rights control access to functional areas of the system such as marketing or the ability to create or edit reports or send mass emails or export data, then you will find that they are subject as well to the same rights, but only at the level of the data. Here we're thinking about much more direct control of data. So any user can access the S data, but what they see is subject to rights. All requests have to be authenticated, and then access to the data is limited in the same way the user's access is controlled within the interface. It's important to note that access to the data via the REST-based interface is controlled by these security profiles. That has the effect of limiting access to rows within entities and views. Field level security also limits the columns that are returned within the generated result set. These settings control a user's ability to insert, edit, or update data within the REST API. A user can be denied access to any main entity within the system. For example, a user may not be allowed to see any cases, and so they would not be able to retrieve any data from that table. If a user cannot update a record, then an attempt using the REST API to perform an edit will return an error. This level of control goes down to individual fields that a user may or may not access. Let's now consider the way in which data is handled. Here's the result of a GET request. You can see that we're calling in to the particular server with SData, CRM J, and then Sage CRM 2, indicating that we're using the REST API / company, and then you've got the specifier of 28. And I've used Postman as my REST client here. Now this is returning data in JSON. But JSON is JavaScript Object Notation, and it's an open standard format that uses human readable text to transmit data objects consisting of attribute value pairs, and it's used primarily to transmit data between a server and a web application, and it's much more accessible in terms of looking at data and working with the data than XML, for example. And data formatted according to the JSON standard is lightweight. It can be parsed by JavaScript implementations with incredible ease, making it an ideal data exchange format for web and for mobile applications. The information transported through JSON is always in the form of the following basic types: strings, double-quoted Unicode UTF-8 by default, with / escaping numbers, Boolean values which are true or false, and nulls. And JSON describes objects. Here you can see on the slide an object using names to access its members. So JSON describes objects. Objects use names to describe its members. In this example, you can see that it's returning the name is Sage. So all the properties and members of the object are unordered. They are only identified by the name. And it's possible to pass sub-objects. So JSON describes, as I said, these objects in unordered sets of name content pairs. The only restriction is that within the set the names are unique, and the name content pairs are separated by a comma and enclosed by these curly brackets as well. And as you can see, we're passing here a sub-object, which in this case is within here a property called association. All the properties and members of an object and all of the sub-objects are unordered and identified only by name. Now, if we look to the data that is available, we can step back and we can think that Sage CRM, following the REST principle, allows for the manipulation of resources. So the Sage CRM REST service represents the objects exposed in Sage CRM, things like the company, the case, the quote, etc., as resources. This means that there's a unique URL that identifies each resource so that you can manipulate it with standard HTTP methods. Now, for our purposes, we have to understand that this is something called a hypermedia-driven API. And this means that the Sage CRM REST API actually returns responses that includes links to the resources available in Sage CRM. The results of a request using the Sage CRM REST API provides the URLs to other allowed actions, and the API resources that are officially documented as supported are shown on screen now. So let's consider the request to retrieve an opportunity record via the API. And that URL will look like, well, there's the server name, SData, the instance name, J, Sage CRM 2 / opportunity, and then the specifier 6. And that's going to result in a JSON package that conforms and describes the resources that have been returned. And so in overall the result set, it's describing the relations of this object to other resources as well. Now you can think of this as a type of dynamic schema discovery, allowing a programmer to create a client application that can interactively explore the data available. And please do note that access to the data via the REST API is controlled by security, as we've discussed. And that includes field-level security. And this has the effect of limiting access to rows within entities and views. A data source for the API can either be an entity or a view, actually, and the view is read-only. But field-level security also limits the columns that are returned within the generated JSON as well. But another way of finding out more about each of the exposed supported resources is to use prototypes. Here you can see a URL that is saying server name, sdata, install name, through to the REST endpoint, and then prototypes. And this describes the resources that are available. And the service is read-only. And it will either get updated or refreshed only if custom entities are added or deleted, or if other changes are made to the exposed entities. And in turn, when the prototype for an individual resource is requested, this then provides information about the fields and allowed values. Here we can go in and see that I've requested the details of the opportunity entity. As part of the documentation for the REST API, we've made available a Postman collection. That's a set of examples that can be used with the Postman REST client to demonstrate the create, read, update, and delete actions on the notes table. Now, within a REST client, it's very easy to perform all of the HTTP verb actions, such as post, put, and delete methods. That begs the whole idea of using the HTTP verb as the indication of the action to take place within the database. So a request for data using the Sage CRM REST API looks like this. So where you can see we're going down to Sage CRM to person, where, and then we've got lower and so on. So the Sage REST APIs fetch the data conform to the idea of a URI, a nice URI. And the URI is for the rest of short and use nouns instead of verbs, because we're relying on the HTTP verb to indicate the action that we're carrying out. So there's a pattern to the way in which we can reference the entities inside the system. You can see here I've got a set of examples of allowing us to how we make different interrogations around the company. So we can looking at the prototype, the schema information for the company here with the SData prototype. We're looking for a specifier to call back an individual company. We've got a range of companies when we're passing other specifiers which are not unique with the where clause, but we also have alternatives, more than one way of specifying the uniqueness of a record. We'll talk about the different result sets that come back in a moment, but for now let's understand that this REST API is available for an external application to call. And that means the API syntax it allows for an external application to form a request that also limits the rows returned. And so here you can see, as part of the specification, we have a listing of companies where the results are being restricted to a result set of 10 rows. Now, I mentioned the different types of responses that can come back, and we've seen that JSON objects are unordered sets of name-value pairs, and the only restriction being that the name-value pairs have to be unique, so the names have to be unique. And when it comes to working with JSON and the REST API, then the results are going to be of particular types. They're basically entry, feed, and diagnosis. So an entry is a representation of an individual resource and contains the native JSON formatted objects. A feed is a collection of entries. That's when you're pulling back more than one record. And a diagnosis is returned in case something went wrong with the request. It's basically the core to error. So first of all, we can think of the request being a get. This is a get that's being used here to get hold of an individual entry. And we can see that this entry is of an individual company. And you can see here underneath where it says the 200 error message, or rather result message, 200 message, the result is describing a single record as a JSON object. If we compare that with a get feed, this is when we're calling back multiple records from the company. There's no specifier to indicate an individual record, even though in this case we're seeing that we're specifying a count of the number of rows, but that still nevertheless results in a set of records being returned. So the result describes a list or set of objects in JSON format. And if we do something wrong, or something happens wrongly when an illegal or erroneous request is made, the result that is returned is in the format of a diagnosis message. And so that's where we might have put in the name of a view or a table that doesn't exist. You can see here I'm calling back the idea of a phone table there. Now you can see that I made a spelling mistake, and this has been made within the name of the table to which a request is directed. And that's a 500 message. And Sage CRM, the API uses different HTTP status codes as part of its representation of operations that you perform against the REST API. And so they're divided into major categories. The actual major categories are success, which is the 200 type messages, 300, which are redirection messages, 400, which are user errors, and 500, which are server errors. And they each mean different things. So with the 200 type messages, that's when the request is completely successful. When you have got a 400 message, that's when a client has performed some sort of action that caused an error. And you might have a 405 or a 404 error, and with a server error message like 500, the server has performed an action that caused an error. Now, whatever those actions are, the examples for inserting, updating and deleting records, etc. are all within inside the online help. All entities are described. And if we're working with those entities, we need to be aware of some of the limitations that exist with working with the REST API. So HTTP requests sent to the REST API, there are some limitations here. So you see that REST API doesn't trigger table level scripts. Do trigger table level scripts. So there's just a few things to mention about that. So REST API calls do trigger table level scripts. You need to be aware that ActiveX objects are not supported. You can't use those. You can find that context established in a table level script is going to be ignored. The values submitted in the HTTP request can't be read using the values and form value system variables. So they're not on a form, so they're not going to be seen by that. So you'd only have access to the core information. But you can use the where clause system variable within the table level scripts, and the values system variable to set values on table level scripts as well, and the whole the key things, which are the valid and error string system variables, can also be referenced and used. Now, our last topic that I want to consider is performance tuning within the REST API. The documentation for the REST API lists the entities that are supported for CRUD actions. For each entity, examples of the JSON payload for each HTTP method are provided. And what's more, the documentation provides a postman collection that I mentioned earlier on that shows how interaction with the notes table can be performed. So we just have to think about the example note that we see here, and that's showing that the request of this screen has been directed at server name, sdata, install name, Sage CRM 2, going into the specifier for notes. So the primary key of the note record is going to be that has to be updated. So we need to specify the primary key for that record. If it's going to be updated, then we need to be able to know that it's included within the specifier. Our JSON package looks like this. and that's going to be essentially the data that we could then submit within the HTTP request using the patch verb or the verb that we want to use to be able to make the update. And if the update is successful, then Sage CRM will respond with a successful 200 message. Now, in that sort of update, there's an assumption that is made. So an assumption is made that if we have submitted the value, then we can assume that the data contained that we know on our side is going to be the data that's actually held inside the database. But we know from table level scripts that actually theoretically that's not quite true, because we could have table level scripts changing the data as it's being inserted. But by default, whenever the REST API inserts or updates a record, the response set is actually read back from memory, not from the value that's submitted and committed into the database. Now, this provides better performance by having to read from memory rather than from reading from the database, and in most circumstances it's reasonable to assume that the data in memory will be the same as the data that is stored in the database. But this may not be true where data transformation takes place because, as I said, a table level script. And to be certain of this, you can see that there's a flag there, return partial false, that can be used within the URL. That brings us to the end of our lesson for today.